To solve another Leetcode problem, 2316, count unreachable pairs of nodes in an undirected graph. Yeah, let's try to use the second example because it's easier to explain. Yeah, so yeah, let's just try to understand this one. So we have a graph like this. So we are going to count the unreachable edges. So for example, unreachable nodes. So for example, 0 to 3, 0 to 1, and 0 to 6. Yeah, so we're gonna use the DFS. So for the first DFS traversal, we're gonna traverse the first component. So for 0, it's gonna be connected to 2, 4, and 5. So we have a count of 4 nodes. Yeah, after the first visiting of the node 0. Then we're going to use this 4 to check how many nodes are left. So there are 3 nodes left. So 4 times 3. Yeah, 4 times 3 gonna be 12. Yeah. And then we're gonna use the DFS to search the second component. For example, we're gonna search this node 3. Yeah. So it has 1 node. Yeah. And we're gonna use this 1 times what's left behind. Left behind there are 2 nodes. So we're gonna use 1 times 2. So what is that? So it's gonna be 2. Do we need to use this 1 times 4? We don't, because there will be a duplicate. So we don't need to count the duplicate. So we just need to, yeah. For the second traversal, after traversal the node 3, we waited 1 node. So this is 1 node. Yeah. And we need to use a set to count how many nodes. And we also need a big set to count how many nodes in total. Yeah, so for example, in total, this is 4, this is 1, this is 5. So what's left behind? 7 minus 5. So left behind is 2 nodes. So there are 2 nodes left behind. So we need to use 1 times 2. Yeah. Next, we're gonna check this one. Yeah. So for this one, how many nodes? We visited 2 nodes. And how many nodes are left behind? So 7 minus 7, it is 0. So 2 times 0, it is 0. So the final result would be 12 plus 2 plus 0. It's gonna be 14. Yeah. So let's just start coding. As I explained, I'm gonna use DFS to solve the problem. Yeah. Let me first write the DFS. So I is the node. So for neighbor, I'm gonna use a visited set as the local set. Just use this set to check like one component. And I'm gonna use a scene as my big set. So I'm gonna use a weighted set. So weighted dot add with neighbor, and yeah, for neighbor in G neighbor, yeah, if neighbor not in weighted, and then I'm gonna execute. So the weighted should add, and the DFS would be the neighbor. Yeah, so this is the DFS part. Now let me just prepare a 2 set. So the visited set and the scene. The scene will be a big set, and then I'm gonna prepare this visited set. It's gonna be yeah, I'm gonna prepare a scene. Yeah, so I'm gonna prepare a scene would be empty set. And also I need to prepare a result. Now I need to loop through all the nodes. Yeah. So if I not in visited, yeah, if I not in scene, because I need to check all the nodes, so I need to use this big set. So if I not in scene, so scene dot add this I, and I'm gonna also use this visited. So the visited should initialized to a set, and inside I'm gonna have a node I, and then I'm gonna execute the DFS. So for the DFS I, yeah. After executing the DFS, I'm gonna use this result plus equal to. Yeah. Now let's go to the mathematics. We're gonna check how many nodes in our current component. So it is the length of visited. And we are going to calculate how many nodes left behind. So it is the length of the it is n minus length of the scene, because this scene is a big set. It's gonna put all the nodes. If it is visited, we'll put inside. And this visited is just a local set. So finally, we're gonna return the result. Yeah, but we didn't prepare the adjacency list. Now let's just prepare the adjacency list. Yeah, it would be a default dict. It is a list. So for uv in edges, so we're gonna use gu dot append v because it is undirected. So gv dot append u. Yeah, so this is the entire code. So we're gonna first prepare an adjacency list, and then we're gonna use the DFS to check. So here I forget to put the scene. Yeah, because this scene should also add the neighbor. Yeah, because this scene is a big set. Yeah, you can see from that this scene is always add, but this visited is just initialized. This is a local set. This C is a global set. Yeah, we're gonna use the global set and local set to solve the mathematical problems because we're gonna use mathematical formula. Yeah, this is why we're gonna use two sets with DFS to solve the problem. Now let me run it to check. If neighbor should not invisited. Yeah, let me try again. For neighbor in, yeah, I did something wrong. For neighbor in GI, I is the node. Yeah. Now as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast and it passed all the testing cases. And basically this problem is just about mathematics. We need to understand about the mathematics, and then we prepare two sets, a global set and a local set, to solve the problem. Thank you for watching. See you next time.